Okay, look here, we got one that's running a little bit fast. I don't know if you're
All the
running anything
students
like this
ain't here.
before. Huh?
All the students ain't in here,
Well, they better come on, that's all they got.
and it's vacuum week.
They're gonna miss out if they don't come on. All right, so, I had my driver's license before I got my driver's license when I was about 13 years old. I used to ride with this friend of mine that was older than me, and he had a Chevy Impala that had a factory vacuum gauge over on the right-hand side, you know, speedometer and all over here, and that's what it looked like. Manifold vacuum, and at the time, I didn't know what manifold vacuum was all about. And I used to sweep up and down with the accelerator movement and all that kind of stuff, and I said, what does it tell you? He said, I don't have a clue, but it moves all the time. You know, he didn't know what it was either. Basically, what you're supposed to do, if you kept it in the green, it helps you get better fuel economy. And his car looked just like that one right there. So anyway, I always liked looking at gauges. You know, I like seeing the needles move around and everything. I asked my dad what a vacuum gauge on a dash of a car was good for. He said, it's something you look at while you're having a wreck. He's got the idea that if it's distracting enough, you're liable to crash. So some gauges aren't necessary, they can be distracting, but I decided in the mid-80s it might be wise for manufacturers to put a fuel pressure gauge on the dash so that people would have an idea what was going on whenever their car stalled sometimes. You know, sometimes they lose fuel pressure going down the road, and whenever it came in, it would be just fine. And sometimes when I'm tracking a fuel pressure problem, if I got a fuel pump that's getting hot and dying, I'll put a gauge on it and I'll fire that thing up and I'll let it run for 4 or 5 hours. And whenever I walk by there after it's been running 4 or 5 hours, when it finally dies, you know, of course I'll know it's not out of gas because it's got plenty of gas in it, it'll die. And I'll look at it and I'll see the fuel pressure gauge has gone away. I crank it up and it comes back up, and then it'll usually fall right back off. I know I've got a bad fuel pump. There was a truck mechanic back there that, you know, was asking me about one he was working on. It was a gas burner, and I said, let it run 4 or 5 hours and it's probably gonna have a fuel pump. And when he found it, that's what it was. But anyway, this right over here on the right, you notice that the European car there, whatever it is, had a fuel pressure gauge, and that's reading bar. It reads from 1 through 5, you know, up that way. Well, even the most necessary gauges can confuse some customers. Now, back in the 70s, we used to have amp meters that just had discharge or charge. If it was a little bit over on the right side of that middle line, everybody felt like it was okay. If it was a little on the left, they know their alternator wasn't putting out. Well, you got an amp meter and a voltmeter, and in the late 70s, they started putting voltmeters on all the cars, and people that didn't know what the difference between amps and volts was would get confused because of where the thing was reading. Some of the voltmeters were read in such a way to where 14 was down kind of low, and it would make it look like it was discharging, and they really wouldn't know how to interpret that thing. So, and there's these temperature gauges on some of your little front-wheel drive cars with electric fans that could climb really high into the normal range, and it scares the daylights out of people that are accustomed to lower range temperature needles. If they're used to, a lot of people for years used to think cooler was better, and if it was down on the low side of the gauge, they'd feel like it was right where it needed to be, but it's really not healthy for an engine. Now, we've talked about this before, so I do a little quiz here. So what is it that, why is it that the engine needs to run warmer?
Because if it runs cold, it don't burn out all the moisture. It has pre-cylinder wear.
Yeah, it will. And if you're, I don't know if you noticed on some of your older V8s, whenever you pull the engine apart, the cylinder that's right behind the water pump, you know, where that runs the coolest is the one that's got the most wear and usually has the deepest ridge. You know, right behind the water pump is usually where you'd see that. Now, nowadays with these low tension piston rings, you don't quite see that the way you used to. And you don't hardly ever have to ream a ridge whenever you get, you know, taking pistons out anymore either. But anyway, but I remember from the dealer days when I worked at the dealers how some people used to complain about carburetor fast idle settings that seemed too high. Well, some of them wouldn't have even noticed the problem if there hadn't been a tachometer to look at. So when they started putting a tachometer on there, people started watching that tachometer and trying to figure out, you know, what was going on by looking at that. And a lot of times they didn't know. And sometimes a false flag because people will say, I don't like this thing revving up like that. Well, the problem was things got worse. One customer complained repeatedly that his 90-85 2.3 liter Ranger was idling too fast at first startup. And what we couldn't seem to make him understand was that that is actually an algorithm that's been punched into the engine controller, and we can't make an adjustment to change that. We can't make it not idle up. Well, in his mind, he had the idea that when you first start one up, it needs to be running really slow because he was concerned about it would damage the engine if it was running too fast and all that kind of thing. And so You know, whenever he left out of there, he went home and he decided he was gonna do something magical to fix that. And so what he did was he took his idle air control off, which is one like this one here has on it, and it's got 2 bolts going in there, and he pulled it off and he put little washers in between the idle air control and the manifold where it went on, and that let air leak in there. And whenever you've got an extra air leak in there, what does it do? Whenever you let more air in,
The car up.
it actually idles up a little higher. But what he was winding up doing was he had it idling up into what we call the dead band. And what that was all about was if it sees it in a range, if the PCM sees the speed in a range that it's happy with, it doesn't do anything with the idle air control, and so the idle air control pretty much goes to sleep. And he was bragging about that and how he had figured it out and we couldn't figure it out. And I says, well, what you hadn't figured out is now you've got the dirt and stuff sucking in there that's going to wipe out the motor if you leave that like that. You know, you can't do that. And he says, well, if they want to pay me for my idea, you know, I'll go ahead and sell them a patent on it. And, you know, I thought that was sort of, sometimes you basically couldn't do that. But this dead band area is one, like if you've got a vacuum leak, sometimes you'll wind up with it in the dead band, and the idle air control won't even be doing anything because it doesn't need to. It's an adaptive learning thing. All right, so for years, automakers utilize vacuum or electric throttle kickers to compensate for engine loads. In other words, they have a little solenoid that whenever you turn on the air conditioner, it kick the throttle up just a little bit so it can maintain its idle. Some of them make basically when you turn the power steering, you know, it would actually have a switch on there. Some of them even use vacuum and they kick the throttle up like that. But there's these old dash pots. See that old thing? You ever seen one of those on a carburetor? That little solenoid, I mean that little, not a solenoid, but it's a little, that little thing, it's not hooked really to anything, but it rests against the throttle plate. You ever seen one of those? Do you know what it's there for? What's the purpose of that? What does it do? Why do they even put it on there? Because it doesn't have wires or vacuum lines or anything hooked to it. Now some of the GMs had an idle load compensator that basically when there was a little less vacuum going to it, it would extend farther. And so that means if you turned on a load on the idle and it would lower the engine vacuum and it would let this thing go out and it would maintain.
Like a choke?
Huh?
Like a choke?
Not really. It actually, the throttle plate, when you give it the gas, it extends just really quick. And when you give it the gas and the lever falls back against it, it goes down slowly. So it keeps your throttle plate from just slapping shut. Because there needs to be a little bit of time on an engine after it's slowing down. If you let, even a fuel injected engine, if you let it come back to idle too quick, it'll stall. And you really don't want that. And so that's the dash pot function. They call that thing a dash pot. First time I ever saw one of those, I asked my dad, I said, what's that? He said, that's a dash pot. And you know, he didn't explain to me what it was because I didn't have time to ask him that day, but I found out later that if that dash pot's not adjusted right, when you let off, even if everything else is right, a lot of times it'll stall. And so that's what the dash pot's about. Now, in the early days of GM's computer command control, most GM vehicles had one of those electric idle speed control motors mounted on the side of the carburetor, which looks like that. You may have seen one of those if you've looked at an early 80s GM. One of the jobs that motor had was the dash pot function. Now Ford had another one, had one too, that was similar to that, but it was a different shape. It did the same job. Now when you let off the gas and it touched that, the throttle contact switch was not built onto the tip of that. The throttle contact switch was inside, going to terminals A and B. And basically whenever you would give it the gas, that switch would open or close depending on how it was designed, and it would tell the computer, which was operating this idle air control, or excuse me, this idle speed control, it would tell it whether you had let off the gas or not. And believe it or not, you can have a lot of trouble with one not running right if that switch is chalked up in there. And I would actually get my meter and I'd measure the resistance of that switch while I was putting my finger on the tip of that, and I would see if I had, like, it ought to have a straight short. Sometimes on some of the Ford ones I'd see 40, 50, 60 ohms, and we'd have to replace one of those. But anyway, that's just and that's what one looks like in the flesh right there, down there on the bottom. There's an adjustment on it, but that adjustment is not there to raise and lower the idle speed. It's basically so that it'll be in the right range when it opens and closes that switch. Now when one of these things is working right, it automatically finds the proper idle speed as AC or power steering loads come and go. So if you turn on your AC or your power steering or something else is going on, you're in parking lot maneuvers or whatever, it's basically going to find that. Okay, now electronic fuel injection became the order of the day on most vehicles by the late 80s, and the TBI and EFI system used by GM and Chrysler favored these little stepper motors, that would basically have 4 little pins in there, and they had a little, that motor armature had a screw on it, and whenever they had, well, there's various different ways, but the ones that I always thought about were the ones that were powered up, and it would dither 3 grounds in there, and it would turn that little thing slowly, and you could screw that hour back in. And it would give it a little, you know, and you could, that's what you see if you look at your, on your GM or your Chrysler or your Dodge or whatever, if you're looking at it, it'll tell you how many steps the idle air control is. Now on your Ford one, like this one over here, it's like a variable force solenoid. It's got 2 wires, it's got a little winding in there, and it's got a spring and a poppet that can move and let air go around the throttle plate. If you let air go around the throttle plate, as you see right there, this is a very simplified diagram of it right here. I keep pointing with the flashlight. Right there, see how when this moves back, see how you got them windings in there, that little stepper motor? When this moves back, air goes around the throttle plate, and that actually changes the idle speed. And your mass airflow will actually be measuring that air too, because it's going to be upstream of there. There's an air passage down there. These like to clog up, by the way. If you want to clean one of those up and wash all that stuff out of there, a lot of times you can make one run a little bit better. How many of you guys have ever changed a battery on something like a Dodge pickup and found out after you changed the battery the darn thing wouldn't idle? If you hadn't run into it, you probably will. You pull the battery out, you have the battery out for a while, you put it back on, you crank it up, it goes dead. Crank it up, it goes dead. Crank it up, it goes dead. What the heck is wrong with this truck? Crank it up, it goes dead. Crank it up, it goes dead. Well, the throttle body's dirty and the idle air control passages are clogged up. And as it lived every day and it got slowly and slowly more clogged, it adapted so that it knew. So whenever you take the battery cable off and you have it off for a while and you wipe the memory, when you put it back together, it has forgotten everything it learned about idling with them dirty passages and is trying to idle like it's a brand new truck. Now if you drive it around for about a day, it'll usually clean up its act and relearn all that hogwash. But the smart thing to do is while you got the battery cable off, go ahead and wash the throttle body out in the idle air control area. All right. So Ford uses the 2-wire idle air control valve. You know what that looks like. I've showed you that before. And the PCM applies current to pull a poppet against the spring to let air bypass the throttle plate. The same thing is being done, but it basically just pulls on, you know, put more and more current on that little poppet it can go back and forth with, and you can basically tell what the percentage is by looking at the scan tool. Now that's an important thing to understand too. The ones that have this vent on them, the one that's got the plastic vent, some have the vent, some of the older ones don't. The older ones that don't have the vent, you can actually clean them. These you're not supposed to clean them, but a lot of guys still do. So basically those passages can get clogged up. And also, by the same time, that EGR that's going through there, it can actually clog up in there too and give you PO 401 codes and all that. So keep aware of that. Now if I had a problem that had to do with the idle air control valve, what series of code would it be? PO what? Like for example, the EGR is a PO 400 series code, right? You got me? So if I've got something related to do with the idle air control valve, what series code would that be, you think? Well, it would seem, I mean, if I was just thinking about this and didn't know, but that's a 500 series code, which is related to speed of the engine or the vehicle. Now, if it's related to the speed of the engine of the vehicle, it's a 500 series code. If it's related to EGR or anything to do with air or, you know, emissions like that, it's basically a 400 series code. Like a bad catalytic converter that's not storing oxygen will give you a PO 420. Then you got a PO 455, it's got to do with your evaporative system, somebody left the gas cap off. You know, 400 series codes have got to do with EGR, evaporative, and exhaust.
Have you ever heard one of them things sound like a hoot owl?
Oh yes. As a matter of fact, when they started doing that, was the first time ones we heard was on the early Crown Victorias, and we actually had to replace the rubber hose that was feeding air to it and put one that had a muffler in there, but it would go, it's terrible noise. And I think, if I'm not mistaken, I had heard that the one on that car out there is doing that. Usually you replace the idle air control valve, they'll take care
Yeah,
of
the
it.
one that was on my car, when I first got it, would do the same thing.
Yeah, so it made you a wise person because you were a hoot owl. All right, so foreign control, I messed that up when I typed it. Foreign controls are the same way foreign cars do, but with more expensive hardware. That includes a hot water passage and a wax element along with electrical elements, and they kind of look like this. And when you have to buy one, it's for $300 to $500. Now that's one of the problems that I have had with some of these. I have seen mass airflow sensors for foreign cars cost $1,200. And I've seen idle air controls, like an idle air control for a Ford or Chevrolet or Dodge, typically costs about 50 to 75 bucks, but one of those is $300 to $500.
I probably went out for like a 94 Honda, it was 350 something.
Yeah, they're high as all get out. And why in the Sam Hill do they want to run water through there? I don't understand the point in that. I mean, it's got a little wax pellet in there that helps, and then you got electric part of it too. And and they're not trouble free. and if they were better quality, that'd be one thing, but they're not. You know, I don't get it. But anyway, adaptive learning strategy brought a whole new dimension. That's what I was talking about earlier. PCM, control of the idle speed. You had no touch starting. There's a lot of people out there nowadays that are driving cars that have never had to pat the gas to set the choke on the carburetor. Just fire it up. And if it won't fire up, some people will fool with the gas. And what happens when do you do anything on a fuel injected engine when you're patting the gas? Huh?
Cuts the injector.
Well, I mean, if you're just patting it, not even going all the way to the floor.
I'm pulling it out.
How does it do that? Wait a minute, there's no accelerator pump, so how are you letting it out?
Because it's telling the injectors to fire more.
Yeah, he's right. Because what happens when you're cracking the throttle, it adds additional injector pulses. However, it needs to know where idle is. When you start it up, that engine controller wakes up and he says, woo, I'm looking at engine coolant temperature sensor, I'm looking at intake air temperature sensor, I'm looking at barometric pressure, I'm looking at all this other stuff. Now I'm seeing engine spinning, now I know how often I need to fire the injectors, got to factor in how wide they need to go, and I need to double pulse them when we're spinning it over and all that, you know. But anyway, this is kind of what the table looks like just for fuel correction. Now, if you ever see these maps, they'll look like a mountain or something that's made out of little blocks. And you basically got multi-dimensional spreadsheets, and each little cell has its own little set of instructions in there. Like, for instance, on your Chryslers particularly, you'll see something that talks about purge-free cells. Now, these are cells where no matter what happens, it's not going to purge the canister, because, you know, that's the ones that you want to make sure that when you're checking it, you're not going to have vapor coming in from the carbon canister system.
Them tunes look like that too.
Yep. Okay, yeah, the tuning that he does is gonna look like that, because that's, you know, he's going into that table. That's what it is. An idle air control actuation changes with age, throttle body clogging, vacuum leaks. Everything is gonna cause this thing to try to keep it balanced in as much as it can. And that's what adaptive learning is all about. Now, one of the inputs utilized by Ford PCMs for this necessary dashpot function is the vehicle speed input, believe it or not. As long as the vehicle's rolling, even if the throttle's been released, the idle speed is deliberately decreased at a controlled rate to prevent potential engine stalls. And you might see right here, the VSS on this scan tool showing 16 miles an hour. Then you got part throttle, which is going to be something I'm going to talk about in a minute. Idle air control's at 70% and the RPM's at 3,269. But this right here would keep it a little higher, but not that much higher. As long as you're rolling, you're going to see a higher one. A lot of folks don't know that. But some of them who hadn't owned their cars very long, like if somebody just got a new car that, you know, you notice everything a little bit more if it's different from your previous car, and they might complain. We used to have people that said, whenever I'm coasting down, when I got my foot on the clutch, even when it's not in gear, my idle speed stays up until I come to a stop and then it comes down. And I said, well, that's just more part of the strategy. They don't like it. They don't know why they don't like it. It's not causing any problem unless they think it might be burning more gas. But when they do notice it, there's not much you can do about it if the strategy is built into the PCM. Now, it's a dereliction of duty whenever one is not fixed right to tell people you're going to have to drive it a few days and let it learn. That's what people say when they're trying to get one out of the shop. All right. Now, the wrinkle comes when you got to determine whether what the customer is feeling is PCM strategy or if there's actually a problem that needs to be addressed. So a knowledgeable scan tool junkie knows idle speed concerns can be generated by a throttle position sensor PID that reflects part throttle reading whenever the accelerator has been released. That's what this is closed throttle. Say CT, and then that's the TP mode. And that's what it looks for. Whenever you first crank it up, it pegs what it sees right here on your TP voltage, and it says, that is my idle. That's one of the things it looks at. That's closed throttle. And it uses that to determine what part throttle or closed throttle is. It doesn't have to go much above that before this starts reading PT, and it starts doing screwy things with the idle air control. All right, so the PCM reads and stores that angle, and that's what I said in big words, in the realm of key on, and uses it to determine when the throttle is off idle, and that's as important for our story. The vehicle in question was a 98 to 2000 Ranger manual transmission 2.5 liter Matt complained of a high idle, 3,000 plus, with the clutch depressed. It doesn't settle down until it coasted to a stop. And if it's something they've only recently noticed, you will need to address it. If they've had the truck for a while, some people, you know, this one guy was telling me that whenever he was driving his Thunderbird, he says, you know, when I first got this car and I drove it for several years, I could just breathe on the key and it would start up. And now I gotta spin it for about 45 seconds before it fires up. And it turned out he had 3 dripping injectors on that one. All right. I've seen several 4-cylinder 98-00 Rangers with high idle coast down problems, and the TPS voltage will hang just above the stored base voltage, which would be, that's what I was showing you earlier, this much. This is at 0 miles an hour, and we basically see this 978 doesn't seem like a lot, but when a customer's watching their TAC, they know where they like for it to be, and they don't like that. Well, the key is part throttle. Why is this saying part throttle? Well, look at that. It was 0.87 before, and now it's 0.94. Why is it higher than it was when I've let off the fuel? I mean the gas, the accelerator. Now the air control's at 35%. See, that's how it reads on one of those, is in a percentage thing. All right, so you fiddle with the TP sensor wires and you watch the scan tool, and if that lowers the voltage, you might have a connection problem at the sensor. So how am I going to fix that?
You can get out here and wiggle your wires.
Well, we've wiggled the wires and we've determined that the part throttle changes to closed throttle, the vehicle idles down, so I need to fix this where it will never happen again. What did somebody say about a pig with tails? What? All right. Let your fingers do the walking. After you pinch and twist the wires at the sensor, the concern might be hard to duplicate. It may go away for a while and not come back. Now, let me ask you this. What if it's Friday afternoon, they're getting ready to go on a trip, they want this fixed, and you ain't got no pigtail? The cause of the poor connection is not usually visible as such with the naked eye. You pull the terminals out, you look right here, they look just fine, right? And even in here, you know, you can take each one of those separately, make sure you keep them in order and you don't get them mixed up, and slide them onto the terminals in the TP sensor and see if they got a nice snug fit. That's an important thing to do too. If they're not, if one of them isn't loose dancing around. Now, this one right here is signal return. That is the TP signal, and this right here is reference voltage. What is this voltage right here supposed to be like at idle? Anybody know? You've been seeing it already. Give me an idea.
Do what now?
What is the voltage on that signal wire supposed to look like at idle? You got your foot off the gas. What am I supposed to see there on the throttle position sensor? We've been seeing it on the little scan tool screens.
0.67.
You're supposed to have a little less than a volt. General Motors usually like for it to be a half a volt. But anyway, that right there is a little less than a volt. Now, what's going to happen if I accidentally cut this wire right here? What's going to happen to that voltage?
Go away.
No, it's going to go to 5 volts. Because what's over here? You got 5 volts. You remove your ground reference, this jumps up to 5 volts. If you remove this reference here, it goes down to nothing. And so basically, if you wanted to check a code that had something to do with that, you would jump into here, or you jump into there and see if the code, you know, changed this way and that. Anyway, you're basically looking at the situation right here, where I'm suspecting these right here because these terminals are fine and the TP sensor's already been replaced. Now there was a TSV, they were struggling with this for a little while. 98.26.8, they had instructions to reflash the PCM, but that didn't work. See this right here? High idle speed, 13 to 1200, 2000 RPM during closed throttle deceleration with the transmission in neutral or clutch depressed. A malfunction indicator lamp illuminated with diagnostic trouble code P0320 stored in memory, and so on and so forth. Light truck 98 and 99 Ranger. The reflash didn't work, so that went bust. Okay, so a later Ford TSV was released in January of 2000 that outlines the procedure for replacing the TP sensor pigtail, which is what you were talking about, on 98 to 2000 Rangers and SHO Tauruses, and that's what this one here looks like. It's pretty important to dig through these technical service bulletins and see what fixes they've come up with. And sometimes you'll have a technical service bulletin like this will supersede the other one and all that. And so they basically had a part number for a pigtail down there. What I didn't like was they would send it with butt connectors. Butt connectors are bad. They are not our friend. No self-respecting drivability guy is going to use butt connectors. Of course, you know, I may get some hate mail on my YouTube channel, but I don't like butt connectors. I've never liked butt connectors, and I've seen them give too many problems. and all that, so
I-
basically,
I had to solder a whole wire harness together the other day.
yeah, that's, well, I've had to do a lot of that too. When I first came to teach here, we cut a wire harness apart on one of them Chevrolet pickup trucks, and I made them solder all the wires back together. We just snip, 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 and I soldered them all back together. So anyway, this pigtail is a viable option. It seems the crimps on the new pigtail might be just as prone to give trouble later on. What's gonna be the difference between the crimps on the new pigtail and the ones on the old one? If the first one gave trouble, why would the old one not? Because they look just alike if you look at them, right? So a conscientious drivability guy, once again, will now use butt splices or Scotch lock. Oxidation and the resulting voltage drop can wreak havoc with sensor signal readings, so let's fix it right the first time. When you've got a sensor that's got a tiny little whisper of voltage, all it takes is a little dab of anything, you can't even see it, to keep it from going. The lady that cuts my hair was complaining that her electric clippers wouldn't stay charged. She said, I paid $300 for these clippers, I paid $100 to get them rebuilt because they won't hold a charge, I don't know what to do. And I said, take a pencil eraser and clean the battery contacts. She said, well, they don't look dirty. I said, clean them anyway. Clean them with a pencil eraser on the charger on those. So she did that, and the next time I went over there, she said, since I cleaned them with the pencil eraser, the charge lasts 5 hours. Where'd I learn that? In 1977, Chrysler had an electronic control system hanging on lean burn system on the side of the breather, and when they started giving trouble, they'd have you unplug the thing, and those little brass pins in there, you'd clean them with a pencil eraser. And that pencil eraser works really good on contacts if you can get on them. Now these little teeny tiny connectors we got now, not so much. Okay, all right, so while the TP sensor pigtail is unavailable, try soldering the crimp on each wire connector. Now this is a really important thing. What you want to do is you want to have these sticking up, right? I had somebody was training one time over there, had these things hanging down when they soldered them, and what happened then? The solder ran down in here and you couldn't plug the darn thing back in. So make sure you got these standing up, so when you solder them, any place the solder goes will be away from this part where the connector plugs in. So we solder all of those, and that took care of the problem forevermore. Never had any more trouble. That permanently repaired every vehicle we ever seen with that particular problem. My dad used to drive a little Tempo, 94 Tempo, and he kept getting a mass airflow system code, and he bought a mass airflow sensor and put it on there. That didn't do any good. And so all I did was I took that red wedge out, pulled those connectors out, and I soldered those terminals with a soldering gun, and all of the codes went away and all the problems went away. So it's the same deal. You see what I mean? There's an extremely low current signal, you got that kind of failure. Always consider that. End of slideshow. Somebody tell me something that you didn't know before that you know now.
Soldering
Huh?
soldering things.
Yeah, soldering them things. That was really good. I'll write that down.
I was thinking,